This is day 2 of graphing tangent. I'm just going to go through and do one cycle of each. I had mentioned in the previous video that I like to do the cycle where it passes through the origin, because then I'd move right half the period and left half the period. I really do think that's the easiest way to go about it. So I'm going to continue to do that. The first thing that I need to do is I need to graph the function without any transformation. So I'm going to graph y equals 4. Notice how I didn't put the negative because I don't want to do the reflection yet. Tangent of 3x. So for this one, a is 4 and b is 3. Remember how this impacts the graph. A impacts the coordinates, and b impacts the period. The period is pi over the absolute value of b. So the period for this one would be pi over 3. When it's time to label your scales, I like to go 4 tally marks to the right and 4 tally marks to the left. I do 4 because of what we did for sine and cosine. That's just what we're used to. And also because when we start moving it left or right and up and down, it's nice to have some of your scale already labeled. Remember, we do 1/4, 1/2, 3/4, and the full period length. Sometimes it's helpful if you write it out. So I know the first tally mark is 1/4 of the period, which is pi over 3. So that makes it easier for me to see that pi over 12 is the first tally mark. The next tally mark is 1/2 times the period, so that makes it easier for me to see that that would be pi over 6. The third tally mark is 3/4 pi over 3. The 3's cancel so that I can see that's pi over 4. And then the last tally mark is the full period length, which I know is pi over 3. The left side is just going to be the negative of those values. So this is negative pi over 2, negative pi over 6, negative pi over 4, negative pi over 3. So you're welcome to go ahead and label all of that, just to help you out. And as I mentioned, I do the cycle where it starts at the origin, and I'm going to move right half the cycle and left half the cycle. So as I move right, I'm going to move up whatever the a value was. Because a is 4, I'm going to use a scale of 1. So it would be right here. I moved right 1 up 4 units. And then after the coordinate, the pattern says there's going to be an asymptote at the next tally mark. Now, when I move to the left, I'm going to move down whatever a is, which is -4. And then the next tally mark at negative pi over 6 would be my other asymptote. So I've graphed one cycle. If I want to do a second, which I'm not going to, but if I wanted to, I could either put a cycle here or I could put a cycle here. It's up to you. Now that I have a cycle, I'm going to do my transformations. Whenever you have a reflection, I recommend you do that first. So I'm going to do that in red. The asymptotes just stay where they are. But the coordinates are going to flip. So this now goes up 4 instead of down. The intercept stays where it is, and it's going to go down instead of up. You can see how it's a mirror image, and we've reflected about the x-axis. Now that wasn't the only transformation, or excuse me, yes it was. It was the only transformation because when I look I don't have an H, I don't have a K. So I guess that means that we are done, okay? It's asymptote, the red graph, and then there's still an asymptote there because I haven't shifted it at all. Let's do number 2. Number 2, the first thing I'm going to do is graph it without that -1 without that k value. So I know that a is going to be 1 and the period is going to be pi over 1, which is pi. Labeling my scale 1/4, 1/2, 3/4. You can label it on the left-hand side too. But remember, I like to do the cycle where it starts at the origin. When I move right one tally mark, I'm going to move up whatever the A value is. Because it's just 1 and I'm going to end up moving it 1, I'm going to use a scale of 1/2. You could use a scale of 1. Honestly, it's just personal preference, however you want to set it up. And then the second tally mark will be your asymptote, which by the way is occurring at half of my full period length. The other half will be on the left-hand side. So as I move left 1, I'm going to move down what the A value was to get a coordinate. And the second tally mark to the left, which is -pi/2, will be my second asymptote. Remember, your tangent function can get close to the asymptote, but never quite touch it. Now that I've drawn my tangent function, the second thing I'm going to do is move it down 1 unit. When I move asymptotes down, you can't really tell, so they're going to stay in the same location. It's only left and right where it's clear to see the movement. But I can see the movement of moving it down with my coordinates. So the red is my new graph. Number 3, graph it without transformation, so just tangent x. Then I'm just labeling my scale. So A is 1. The period is going to be pi because it's pi over 1. 1/4, 1/2, 3/4. Following the pattern. Hopefully, you're starting to pick up on it by now. The second thing I'm going to do is the transformation. So because it's the form x minus h, I know that h is a -pi/2, so I'm going to be moving it left pi/2 units. Now, pi/2 is 2 tally marks. So I need to move each asymptote and coordinate left pi/2 units. So my new asymptote is here at -pi. Then I'm moving my coordinates left 2 tally marks. And then I'm moving my asymptote, which was originally at pi/2, to 0. So the red graph is my final tangent function. Number 4, I'm going to go ahead and graph tangent x. I'm going to do that really quick because we should know how to do that by now. I'm hoping you're picking it up. Oops. And then I'm going to use a scale of 1/2. Personal preference, like I said. Okay. Again, I like to do a cycle that starts at the origin. So I'm going to move right 1 tally mark, up 1, and then an asymptote at the second at pi/2. Left 1, down 1, and then at -pi/2, I have my other asymptote. Now, transformations are the second step. I say do the reflection first, then move it. So your red graph is the reflection, which is where you just rotate it, or excuse me, reflect it about the x-axis. And then my green graph is going to move it up 3 units because now I have a k value. I can tell because it's on the outside. When it's inside the parentheses, it's h. So since there's no parentheses, I know it's a K. When I move the asymptotes up 3, you can't really tell because it's already vertical, so they're going to stay in the same location. And then where it's visible is going to be the y-axis. 1, 2, 3. Had you used a scale of 1, this could look a little bit different. 1, 2, 3. By the way, make sure you're using your red graph and moving it up 3, not the purple. So purple was the original, red was after the reflection, and then moving the red up 3 units gave me my green graph. You might be at the point where you're ready to try these on your own. So if you are at that point, you can pause the video, attempt it, and then hit play to check your work. Otherwise, if you're still confused, just follow along. The first thing you should do is without transformation. So I'm just going to do y equals tangent x. Because a is 1, I'm saving the negative, the reflection, for later. And then b, there's no number in front of the parentheses, so it's just going to be 1. A is 1, so that affects the coordinates. B is 1, so that impacts the period. It's pi over absolute value of 1, so pi over 1 or pi. Labeling my scale, remember, we do 1/4, 1/2. Oops, 1/4, 1/2, 3/4, and then the full period length. I also am going to put 4 tally marks on the left-hand side. And I'm going to do the cycle that starts at the origin. So I'm going to move right and then up 1 unit, left down, and we have our asymptotes at positive pi over 2 and negative pi over 2. That should be the easy part for us by now. Transformations are second, and I say do the reflection first. That's just going to make it easier on yourself. So you can check and see that my red graph is in fact a reflection. So now when I have the h value, h is a negative pi over 4, so I'm going to move it left pi over 4 units. Make sure you're moving the red graph, and we're also moving the asymptotes. Pi over 4 is 1 tally mark on the x-axis, so I'm just going to go ahead and move everything that I need to left 1 tally mark. And you can see the green graph is my final function. Number 6, the first thing I'm going to do is graph y equals 3 tangent of 2x. 3 is A, 2 is B. So tangent has a period of pi over b, so it's going to be pi over 2 this time. We need to keep that in mind when we're labeling our scale. So the first tally mark is going to be 1/4 of pi over 2, which is pi over 8. The second is 1/2 of pi over 2, which is pi over 4. And the third tally mark is 3/4 pi over 2, which is 3 pi over 8. And then the full period length, pi over 2. Putting 4 tally marks on the left-hand side is just going to make my life a little bit easier. I like to do the cycle in the origin, moving it right 1 up 3 units because A was 3. I'm going to use a scale of 1 on this one. Left moving down, and then I have asymptotes at positive pi over 4, negative pi over 4. So there's my cycle. Now I recommend doing the reflection, which we can see here. My red graph, asymptotes are still in the same position with the reflection. And then I had a K value, so I'm going to move it down 4. Move your asymptotes, you move your coordinates. Make sure you are looking at the red graph. The graph after the reflection. And because I moved down 4, the asymptotes are in the same location.